In this video, we are going to look at simplifying rational expressions. I like to think about a rational expression as a fancy fraction because these fractions have variables in them. And simplifying a fraction really means reducing it. So another name for this lesson could be reducing fancy fractions. So let's recall what happened when we just simplified a regular fraction. So we're going to simplify 6 over 26. So chances are when you learned how to simplify 6 over 26, you asked yourself what was a common factor that they both shared. And you divided them both by 2 since 6 and 26 both share a factor of 2. So 6 divided by 2 is 3, and 26 divided by 2 is 13. So 6 over 26 is the same thing as 3 over 13. Well, another way to look at simplifying this fraction, and this is how we're going to look at these fancy fractions, is that we're going to factor the numerator and the denominator, and then go from there. So if I rewrite this problem, 6 over 26, and I ask myself, how would I factor 6? Well, 6 is really 2 times 3 when you multiply them together. And 26 is the same thing as 2 times 13. Now that I've factored this fraction, I'm going to cancel out the common factors. Well, the numerator and the denominator both share a 2, so I'm going to cancel those common factors, and then I'm still left with 3 over 13. So this is the approach that we're going to take for these fancy fractions. We're going to factor the numerator and the denominator, and then we're going to cancel the common factors. So when they cancel, they're really becoming ones because 2 divided by 2 is 1, but we don't write the 1. We just assume that when you cancel them, it makes a 1. Let me show you what we're not going to be doing. You know that if you were asked to simplify 6 over 26, you wouldn't say, oh, they both have a 6, so I'm going to cancel the 6. So I know that that means there's a 1 in the numerator and a 2 in the denominator. You know that you wouldn't do that. That's bad stuff. That's illegal math. That's wrong all over the place. So we're not going to do that for our fancy fractions. In order to cancel, you need to make sure that you've factored. So just because they both share an x doesn't mean you can cancel the x's unless it's in factored form. So here are our steps for simplifying rational expressions. We're going to factor the numerator and the denominator, and then we're going to cancel the common factors. So this is going to be a big lesson on factoring, or a review lesson. The first one we're asked to simplify is 4x minus 8 over 5x minus 10. So when you're doing all this factoring, you might want to have a place that you can do scratch work off to the side of your paper. So I'll do it over here, and I'll look at the numerator, 4x minus 8. Well, it's a two-term polynomial, so the only way I'm going to be able to factor this is if it has a GCF or if it's the difference of squares. So we know it's not the difference of squares, and I do see that they both share a common factor of 4. So I'm going to pull out the 4, which means I'm dividing each of these by 4. And when I divide them by 4, I'm left with 4 times x minus 2. So this is the factored form of the numerator. So I'm going to go and write it underneath. Now I'm going to do the same thing for the denominator. My denominator is 5x minus 10. And when I go to factor it, I ask myself, well, what is something that they share in common? Again, it's not the difference of squares, it's just the GCF. And they share a common factor of 5. So I'm going to divide each term by 5, and then I'm left with x minus 2. So I'm going to put the factored form of the fraction in the denominator. All right, now when I look at this, I can tell that I've already factored it. So now I'm going to look to see, do I have common factors? Yes, the numerator and the denominator both have an x minus 2. So I'm going to cancel that common factor, and that leaves me with 4 over 5 as the simplified fraction. Let's look at another example. Now we have x minus 5 over x squared minus 25. So I'll do my scratch work off to the side, and when I look at x minus 5, I can tell that there's nothing to factor there. So I'm just going to go write it back in the numerator. And if you want, because it's two terms, you can write it in parentheses so you can think about it as a unit. And then I'll look at my denominator, x squared minus 25. Well, it's a two-term polynomial, so the only way you can factor a two-term polynomial for your purposes is GCF, or the difference of squares. And yes, it is the difference of squares because we have x squared is x times x, and 25 is 5 times 5. So I'm going to rewrite this as x minus 5 times x plus 5. And as a reminder, the order doesn't matter. You could have had it written as x plus 5 times x minus 5. All right, so now I'm going to put that back into my fraction. Now that I've factored, I get to look for common factors. Well, I see that both the numerator and the denominator share an x minus 5. So I'm going to cancel that common factor. That leaves me with x plus 5 in the denominator. But remember earlier I told you when you have common factors, they cancel as ones, but we just don't write it. So hopefully you see that you still have a 1 in the numerator. And you need to keep that 1 there in the numerator because that is what is holding the x plus 5 down in the denominator. So our simplified fraction is 1 over x plus 5. And number 3, we have x squared plus 7x plus 10 over x plus 2. So remember, we can't go and do any canceling until we factored. So I'm going to take my numerator and I'm going to look at it off to the side and ask myself, how would I factor x squared plus 7x plus 10? It's a 3-term polynomial. There's no GCF, so we know we're just going to jump right into split B. So A times C is 10 and B is 7. So I'm looking for factors of 10 that add to 7. So that's going to be 5 times 2 because 5 plus 2 is 7. So I'll split up B into an x squared plus 5x plus 2x plus 10. Now I am going to make my groups, and I'm going to pull out an x from the first group. That leaves me with x plus 5. Bring down that plus sign. What does the second group share? It shares a 2. So when I pull out a 2, I'm left with x plus 5. My binomials match. I'm going to pull that out in front. So x plus 5. Put those leftovers together, times x plus 2. So this is the factored form of the numerator. X plus 5 times x plus 2. All right, now when I look at my denominator, I can see that there's no way to factor it. It is 2 terms, so I'm going to go ahead and put it in parentheses so I can think about it as a unit. All right, now that I've factored, I get to cancel. All right, what do they share in common? They share an x plus 2 in common, so I'm going to cancel that out, and I'm left with x plus 5. Now you don't need to write the 1 underneath because it's assumed. So my final answer is x plus 5. And at this point you don't need to wrap it in parentheses. You can if you'd like. I did, but you don't need to. It's not necessary at all. All right, so again, the big picture is that you've got to factor before you can cancel it. If you jump in and start canceling, you're going to end up making some very bad mistakes.